Hi everyone, this is Kona, and I'm going to go over simple linear regression in Minitab. So this is just the directions and kind of some basic understanding of how you do it in Minitab. The actual example of doing it in Minitab will come in a different video. So regression uses one or more explanatory variables, so x, to predict one response variable, y. The simple linear regression equation, you've got your little y hat, which is your response variable, which is mean of y for a given value of x, is equal to the y-intercept plus slope times the x value, where your x value is your explanatory or predictor variable. And simple linear regression equation is basically your line of best fit, which is a straight line that best represents the data on a scatter plot. And this line may pass through some of the points, none of the points, or all of the points. So something new, though, from last week that we didn't cover are residuals. And these are the estimated y values. So the estimated y value, this little y hat, so that one. So it's the estimated y values are found by plugging in the original x values back into the regression equation. So this is the x value right there that I'm talking about. So basically you're taking this, so once you find this regression equation, you would put your x value back in, and you get the y-intercept and the slope. You put the x value back in to get your y value. So then the y value are the difference between the observed y and the estimated y. So then the observed y would be what you actually have, and the estimated y would be what this is. So you're never going to have to do this by hand, so it's not truly important that you understand every detail of that, as long as you get that the residuals are the difference between the observed y and the estimated y, and the smaller, closer to zero, the residuals, the smaller the residuals are, the better. So basically, you want the observed y and the estimated y to be as close to the same as possible, which is why it'd be closer to zero. So what does that look like? It looks like, so here you've got the observed is 11.0431, and the expected is whatever this point is right here, so going across. So it would be there on the number line. And in this case, the 11 doesn't really make much sense. But just be thinking about that's where it's coming from. So the residuals squared, or R squared, or it might show up just as R-SQ, is the square of the residuals, or the explained variation, total variation. This is a measure that you will be talking about when you kind of do your write-up of things for this example, or for this type of test. And the R squared is the measure of how close the data are to the fitted regression line. It's always going to be between 0 and 100%. 0% indicates the model explains none of the variability of the response data and its mean, and 100% indicates the model explains all the variability of the response data around its mean. So in general, the higher the R squared, the better the model fits your data. So above 75%, it's a very good fit. 50 to 75% is a good fit. 25 to 50% is fair, and below 25% is poor. And when would you do a regression? Before a regression is done, the correlation should be checked to see if there's any correlation or not. If there is a significant linear correlation, so p-value from correlation is less than 0.05, then you can perform the regression analysis to find the equation of the best fitting line. So this thing, this right up here. So steps for the simple linear regression. So first of all, we are testing for statistical significance of the slope. So the first thing you need to do are check the assumptions. So in Minitab, you would go to Stat, Regression, Fitted Line Plot, where your response y and explanatory predictor is x. And then you would do the type of regression model linear, then the graphs. You would do normal probability plot of residuals and residuals versus fit. So those are the three different figures, graphs that you would do. Then, based on those, you would check for linearity, equal error variance, independent observations, and normality varies. I'm not going to go into this a lot because there's so much here that that's just a completely different video. So make sure to look for the video and watch the video where I explain these four things, because that's actually, you have a quiz on this, so it's important for that, but also you will have homework and you'll have to talk about it for your project. So that's why I'm just doing those 4 things as a completely separate video. Write the original claim. It is two-tailed, and basically for the null we're saying that the slope is equal to 0. Alternative, the slope is not equal to 0. Or in words, there is no significant prediction of y variable by the x variable, or there is a significant prediction of y variable by the x variable. You would calculate the appropriate statistics in Minitab. So stat, regression, regression, fit regression model, the response y variable, and then continuous predictors of your x. This kind of goes back to what we've been doing all along of, is there enough evidence? If p is less than or equal to 0.05, there is enough evidence, which means x can be used to predict y. If p is greater than 0.05, there's not enough evidence, and having information about x does not provide any information in predicting y. We also will look at if there's any outliers, and that information comes from the actual data. If yes, is there a clear pattern? You make your decision. Is not, reject, support, and your real-world conclusion. So that's just kind of a brief information about doing the simple linear regression in Minitab. And and the residuals. So why we want the residuals? The big thing is the residuals, the R-squared here, which tells us how good the fit is. But then also for here we have our normal probability plot of residuals and residuals versus fit. And those are two different graphs we're going to be using. And it actually, so we're using residuals to kind of check these 3 things to see if we can use the linear regression. So that's kind of where the residual things comes in. I hope this helps, and make sure to check out the next video.